Alright, in this video we're looking at solving linear equations that have fractions in them, and these fractions also have variables in the denominator. So when we look at these problems, we have to first figure out how to simplify the equation in the beginning to make it easier to solve. So the most common technique people use to handle these equations is to remove the fractions by basically multiplying every term in the equation by the least common denominator. So look at example A here. The LCD for this equation would have to be x minus 5 because that's the only denominator we have in the problem. Now from there, if that's your LCD, what we're going to use it for is to multiply every term in the equation by that LCD so that we can cancel out the denominators. So we'll multiply it by x minus 5 there, we'll multiply this term by x minus 5, and then we'll multiply the 2 by x minus 5. So remember, every term gets multiplied by that LCD, not just the fractions. Alright, so let's see what that ends up giving us. So the x minus 5 here will cancel with the x minus 5 here, leaving only 3x. Then we'll have the equal to sign. The x minus 5 will cancel with the x minus 5, leaving you just negative 6. And then we'll have minus 2 times x minus 5. Alright, so now we'll continue with the normal procedure to solve equations, the SAM-C approach, right? So remember, we're going to simplify first, and that means we need to distribute and combine like terms. So we have distribution here, so negative 2 times x. Let's rewrite the first part of the equation here. And then negative 2 times x will give you negative 2x, and negative 2 times a negative 5 will give you a positive 10. Now from there, let's combine like terms on the right-hand side of the equation. The negative 6 and the positive 10 can come together. That will end up giving you just positive 4, and then minus 2x on the right-hand side, and you'll have 3x on the left. Alright, from there we want to use the addition property of equality. We're going to try to get the x's together on one side of the equation, away from the other numbers preferably. So I'm going to add 2x here to the right-hand side of the equation. That will cancel out that on that side, but remember I have to do it to the other side. Whatever we do to one side, we do to the other. So I add 2x to 3x and I end up with 5x. And that is equal to 4. Now from there I need to use the multiplication property of equality. This is 5 times x, so I have to use the inverse operation, which is division, to get rid of that 5, and I'll do it to both sides of the equation again. So the 5 divides by itself, leaving you just 1x, and that'll be equal to 4/5. Okay, now one thing we do want to check here, so we usually should check our answer to see if it works in the equation, but beyond that, what I want to check is to make sure that this number does not make the original denominators 0. Remember, if we have a 0 in the denominator, the fraction becomes undefined. But it turns out the only number that's going to make that denominator 0 is 5, right? Because x minus 5 is only equal to 0 whenever x is equal to 5. So 4/5 is not 5, so we're safe. We can use 4/5 as the answer. So assuming we did our work correctly, that is the solution for the problem. Okay, let's look at B now. In B, we could repeat the same procedure we did in A. However, there's something different about B that wasn't true for problem A. If you look back at the original problem here in A, you had a fraction equal to a fraction minus a constant, right? So because of that, we couldn't actually use cross multiplication to simplify the equation to start with. But for B, we don't have a constant over here, right? We just have two fractions set equal to one another. Whenever you have two fractions set equal to one another, you are free to use this cross multiplication idea. In other words, we can multiply the denominator of one fraction times the numerator of the other, and vice versa, the denominator of the second fraction times the numerator of the first. And what that's going to end up giving us then is 6w minus 4 times 5w plus 1. And that will be equal to 15w minus 3 times 2w plus 3. So basically it's the denominator of one fraction multiplied by the numerator of the other on each side of the equation. Alright, from here let's go ahead and distribute and combine like terms. So we'll have 6w times 5w, which is going to give us 30w squared. Then 6w times 1, which is going to give you just 6w. Then minus 20w. And then lastly, minus 4 times positive 1, which is negative 4. And that will be equal to 15w times 2w, or 30w squared. Then 15w times 3, which is positive 45w. And then from there, we'll have minus 6w. I'm going to write that just below here because we're going to run out of room otherwise. And then finally, minus 3 times positive 3, which is going to give you negative 9. Okay, let's combine like terms then. We certainly have like terms on the left here. We can say that that's 30w squared. The 6w minus 20w is going to give you negative 14w minus 4, and that will be equal to 30w squared. 45w minus 6w is going to give you a positive 39w, and you have minus 9. Okay, so we combined like terms on both sides of the equation. Now from here we want to go ahead and use the addition property of equality to move the w's together on one side and the numbers on the other side. If I subtracted 30w squared from both sides of the equation and line those up, what ends up happening is these w squareds cancel out, so I don't have a squared term anymore. Then, for example, I can move the 39w to the left as well. So let me rewrite my equation first. I'll have negative 14w minus 4 is equal to 39w minus 9. So I could, for example, subtract 39w from both sides of the equation next. So these two will cancel out, and then I'll have 39 and 14 added together because they're both negative. So that ends up giving you 53w, or negative 53w, minus 4 is equal to negative 9. Okay, and the last thing we're going to do using the addition property of equality is to add 4 to both sides of the equation. So I'll add 4 here on the left and add 4 here on the right. Now, that'll give us negative 53w is equal to negative 5. All right, so we'll move this up just a little bit to give ourselves some room. And remember, if we have negative 53 times w, in order to get rid of the negative 53 that's attached to the w, we'll have to divide by the same quantity. So we'll divide by negative 53, both sides of the equation, and we end up having simply that w is equal to 5 over 53. Remember, our negative over negative will become a positive. So the answer to this question is 5 over 53. Now we should check to see if this answer is the solution to the equation. We can do that, but more importantly, we also need to check to make sure that it does not make either of the fraction's denominators 0. Because remember, we don't want the fraction to become undefined. All right, so let's go ahead and check that first. So if we look at the 15w minus 3, when will that be equal to 0? Well, if I move this over, it'll be 15w is equal to 3. And then if I divide both sides by 15, we can see that it's whenever w is equal to 3 over 15. That's the only time the denominator on the left will be 0. And that's okay, because that means that our answer will not make the fraction on the left undefined. Let's take a look at the second fraction. When will 5w plus 1 be equal to 0? Well, again, if I move that over, I'll have 5w is equal to negative 1. And if I divide by 5, I will end up with negative 1/5. So the only time the second fraction is going to be undefined is whenever the answer is negative 1/5. Well, our answer is not negative 1/5 for the problem, so we're safe again with this solution. All right, so it looks like our answer is 5 over 53.